Okay, so we discussed tutorial question. Start with objective question. This one is tutorial 8. Which of the following is not true about Huygens principle? So you know that Huygens, what is Huygens principle, right? So the phenomena of diffraction can be understood using Huygens principle. That one is correct. Huygens principle states that each point on a wave front may be considered a new wave source. This one is correct as well. Huygens principle applies only to sound wave. This one is incorrect. So the answer is C. Okay, Huygens principle suggests that the new wave front form move into the regions that it will not reach otherwise. Okay, this one is correct as well. Okay, the answer is C. Okay, for question 2, it says that figure 8.1 shows an experiment which has been set up to demonstrate two source interference. Okay, signal detector move from O towards point X, and as it reach point X, the signal detects decrease. So decrease means over here is disruptive interference. Okay, why this one is called interference? Because this is a young double slit. Okay, and then we also know that for young double slit, it is actually in phase interference. So for disruptive in phase, the path difference should have half. So S1x minus S2x minus S1x needs to be lambda over 2. Okay, you can recheck with your notes to double confirm. Question number 3, a monochromatic light illuminates two narrow parallel slits. The difference pattern observed, in which way will it be possible to increase the separation of the fringe? So basically, if you want to increase the separation of the fringe, basically you want to increase delta y. Okay, so if the question asks you to explain, you have to explain something like this. Okay, from equation delta y equals to lambda d over d. Okay, therefore you can say that delta y is directly proportional to lambda. So if you use higher lambda, if lambda increase, delta y increase. Okay, pattern becomes wider. So the answer here will be donkey, higher wavelength. Okay, question number 4, the interference in thin film is because film reflects some light, correct. Film is thin enough, correct. Reflected ray undergoes fast change, correct. So the answer is donkey. Which of the following statements is true about diffraction? Two sources are involved, incorrect. Width of bright and dark fringe is the same, incorrect. Intensity almost equal, incorrect as well. So the central bright fringe is wider than other bright fringe. That one is correct. So the first three is actually for interference pattern. Okay, now let's try to look at question number 6. Okay, question number 6 says two coherent point source S1 and S2 emits wave with a wavelength of 6 cm. Stand and explain whether constructive or destructive interference occurs at point X, which is 72 cm from S1 and S2. Okay, say that the first thing that it says is that the lambda is equals to 6 cm. Okay, and then if you have two slits, okay, so and then it says that the distance S1 and S2 is equal. So basically it can be three positions, right? It can be above, below, or in the center. So if the distance is equal from this slit, so basically it will be like this lah. If it is like this, then that means this one is longer than that one, so that one is incorrect lah. So the actual position of X actually is right in the middle there. Oops. Okay, and if S1 and S2 emits a wave that are in phase. So let's say this one is in phase. Okay, because S1 and S2 are the same, right? So delta L is basically S1x minus S2x, right? If this one are the same, which is 72 minus 72, this one will be equals to 0. Okay, so if it is in phase and when it meets over here, you will expect it will meet the same, something like this lah, like kaki kiri kaki kanan, right? So bila dijumpa dia still kaki kiri kaki kanan. So over here we create a constructive. Okay, we call this one is in phase constructive interference. Okay, so if you have, yeah, this one is for A1. A2 initially is antiphase. So basically, just copy everything. Okay, initially it is antiphase, like one is upside down, another one is upside down. So when it meets, we meet something similar like this. So when it meets, this one will create a destructive. Above here it creates a constructive, right? So this one is called in phase destructive interference. Okay. For B, okay, for question B, it says that point Y, which is 60 centimeter from S1 and 50 centimeter 51 centimeter from S2. Okay, so for this case, maybe if I want to draw, again you still have two slits. Okay. You can imagine that the S2 distance is actually shorter compared to S1. So maybe if S2 is below here, S1 is over there, so you expect that the position is somewhere over here, a bit below. So this is point Y. Okay. Yeah. Oops. Okay. So S1, let's say S1 is equals to 60 and S2 equals to 51 centimeter. Okay, so if you calculate your delta L, this one will be S1Y minus S2Y, which is equals to, this one becomes 60 minus 51. So delta L is equals to 9 centimeter. Okay, and if I want to write in terms of lambda, since lambda is equals to 6 centimeter, okay, I can say that delta L is basically 3.5 lambda, or 1.5 lambda. Lambda plus half lambda. Okay, so the key thing here is the half lambda here. Okay? So if you have half lambda, if initially it's in phase, so you still have in phase and antiphase, right? Okay, I just copy this one first. So for question 1, B1, it says that it's in phase. So initially they both in phase. Okay, so kaki kiri lah. So when they meet over here, because there's a difference of half lambda, because the other one travels extra half lambda, so accidentally this one becomes opposite, like that. So because it's opposite, then it becomes destructive. So this one becomes destructive in phase destructive interference. Okay, for this one initially is antiphase, right? satu kaki kiri, satu kaki kanan. But then because of the distance, they want to travel extra distance of half lambda. So accidentally this one becomes the same. So this one becomes kaki kiri lah. Okay. This is what we call antiphase constructive interference.